लिखा फटाफट ज्वाइन करें।
Good evening, sir.
Good evening. Okay, just in 1 minute we are starting with the class. Wait everyone for 1 minute.
Good evening, sir.
Good evening. So in the last class we had done about the forces and their types, right?
Yes, sir.
We had seen what are balanced and unbalanced forces. We had also seen what a balanced force can do and what an unbalanced force can do. Okay. Then we had seen contact and non-contact forces also. So we had seen contact and non-contact forces. So what are contact forces?
Muscular force.
Hmm.
Frictional force.
Frictional force.
Sir,
Okay.
the forces which act upon physical contact is known as contact force.
Yes, the
The
forces which
muscular
act.
force is which we apply force on our muscles and do a work or do an.
Okay. The force applied by the muscles to do our work is called as the muscular force, and this force is also a contact force, right?
Yes, sir.
Okay, so just having a quick revision of what we did, and then we move further. Okay, anyone having any doubt?
No, sir.
Amatul Rahim has given message. Fine. Everyone's camera should be on. Let us see here. We have a quick revision note for force and pressure. So, up to now, we have not done pressure. We have just done force. And another very important concept that we will learn here about the forces, which you may not find written over there. So see, we have done what a force is. What is a force? A push or pull that changes or tends to change the state of rest or of uniform motion of an object, or changes its direction or shape. So what all forces can do? From this only we can identify that force can bring an object in motion. It can make an object at rest. It can change the state of motion of an object. It can change the direction of an object, or it can change the shape of an object. Okay. Force can change the shape of an object also. For example, we have seen the change of shape of a balloon, this a change of shape of a sponge, the change of shape of a spring. Okay. So we observe that force can bring about a change of shape also. Then a force arises due to the interaction between two objects. A force is actually an interaction between two objects. When two objects are interacting with each other, then only we observe a push or a pull. A force has a magnitude as well as direction. So we had seen that force has magnitude as well as direction, and we call such quantities as vector quantities. This is a new term for you, that the force which has force is a vector quantity. It has magnitude as well as direction. Okay, so force will have magnitude as well as direction, hence we call it as a vector quantity. So force is a vector quantity. Everyone will remember this, that force is a vector quantity.
Sorry, sir, I didn't. Force is a vector quantity.
Yeah, vector means it has magnitude as well as direction. Force has a direction.
Okay, sir.
A change in the speed of an object or the direction of its motion both implies a change in its state of motion. So even if you have a change of speed, so there is, or you have a change of direction, it means that there is a change of motion of that object, change in the state of motion. So this can only be brought about by a force. Okay. Force acting on an object may cause a change in its state of motion or a change in its shape. So force can act on an object with or without being in contact with it. So the forces which act when they are in contact with each other, they are called as contact forces, whereas the forces which act without a physical contact, they are called as non-contact forces. Okay. So can you give the example of non-contact forces?
Gravitational force.
Gravitational force and
So electrostatic force, magnetic force.
electrostatic force and magnetic force.
Magnetic.
The
Very good.
gravitational force.
Gravitational force, electrostatic forces, and magnetic
Magnetic
forces.
force.
Yeah, these are the forces which we see, or these are the forces which have only. These are the forces which
Muscular
are
forces.
non-contact. Yeah, muscular force is a contact force.
Contact force. Muscular
So
is
we are
contact.
discussing only about the non-contact forces. Observe that the non-contact forces are the forces which can act between two bodies even when there is no physical contact. Fine. Mhm. Okay, so
Sir,
yes,
I have Pearson Trishna physics book seventh class. Sir.
okay, you have Pearson book, right?
Sir,
So
but
see,
even this NCRT textbook is also okay, sir.
you
It's the
see,
same
this,
syllabus.
yeah, NCRT book is okay, but when we are here at Chanakya, we are preparing for a higher level. Okay,
Yes, sir.
whatever
Yes,
is,
sir. IIT
yes,
Foundation.
Yes.
yeah. So this is IIT Foundation. So what I am looking that from now onwards, I will be following this book. Okay,
Yes, sir.
so
It's
this will
good.
come. Yeah, so this you will be getting a lot other than what is there in NCRT. Okay, we have done what all was there in NCRT. From NCRT, we have discussed about the forces. Okay, and now we will be dealing with these terms. See, measurements, kinematics. You will be dealing here in detail in electricity, magnetism, electromagnetism, sources of energy. There are other chapters also.
We
Okay, so
actually
once,
in seventh class, sir, I have actually have in e-physics. They named e-physics extra class for physics. They gave us kinematics, but ma'am didn't teach not anything about interestingly about it.
okay, so we'll be teaching here. We'll be teaching these all things. But our first target is that we'll be finishing our NCRT. Okay, since our NCRT is followed everywhere in the schools. So first we will be completing the NCRT and then we will be moving on to the. Okay, we will increase our knowledge from here so that you people can give your Olympiad exams also. Okay, so you people can give your Olympiad exams. First, we start with the force. We have understood about the forces. I just wanted to see what all chapters are here. So, see, in the contact forces, we have seen the muscular force, that is the force exerted by the muscles of the body. Mechanical forces, the force produced by a machine, that is also a contact. Can you see a machine transferring its force without any contact? Machines require a physical contact to transfer their work, to transfer their force. For example, we have observed, if you observe the machines, So they transfer some mechanical force. With the help of the mechanical force, they can transfer some amount of energy. They use the help of gears, pulleys, belts. They are used to transfer the amount of force. Frictional force is also a contact force. We have seen that the force of friction act only when the two bodies are in contact with each other. Okay, so the force that all it is the force, frictional force is the force that always opposes the motion of an object. The force offered the force that always opposes the motion of an object is the frictional.
Sir,
Then
like
we
throwing
have
a ball.
throwing a ball. Okay, motion of a ball. Instead of throwing a ball, we'll say the motion of a ball is opposed by the floor in contact. So
Yes,
therefore,
sir.
it is the frictional force is acting between the ball and the floor.
Like good Raj.
So the next we had just studied about the non-contact forces. The non-contact forces, they are magnetic forces. That is, a magnet exerts a non-contact force on object made of iron, steel, cobalt, or nickel. So these four names you should remember: iron, steel, cobalt, or nickel. These substances, they are called as magnetic substances. Okay, as these substances can be attracted by a magnet. It's not only iron. Iron, steel, cobalt, or nickel can be attracted by a magnet. Okay. A copper will not be attracted by a magnet, but these things will be attracted by a magnet. Steel, cobalt, nickel, they will be attracted by a magnet. Then you have the electrostatic forces, the force which result due to repulsion of similar charges or attraction of opposite charges. Okay. The force which result due to repulsion of similar charges or attraction of opposite charges, as we have seen that the similar charges repel each other, opposite charges attract each other. So the force between the two charges, that is the electrostatic forces of attraction or repulsion. Then the gravitational forces, the force that exists between any two masses. So this currently you may not believe that the gravitational force exists between all the masses. All the masses. That means if you have observed, if you think that the gravitational force act between the earth and other objects, the gravitational force act between earth and sun, the gravitational force act between earth and moon, the gravitational force exists between earth and a ball thrown upward, right? So this is not the only gravitation. Gravitational force exists between all the masses. That means that there is a gravitational force between your body and the nearby objects. You are attracted by a gravitational force by all the objects around you. They are also taking up the gravitational forces around you. Okay. So this gravitational force, why we are not able to feel that gravitational force? Can anyone tell? We can feel the gravitational force of Earth, but why we cannot feel the
Sir,
gravitational? Yes.
sir, because gravitational force, we can't feel the gravitational force because it is in the space, like it is in the air.
No, gravitational force is everywhere. Suppose what I am saying. Suppose you are standing somewhere. Okay, so let's say you are standing here. Okay, in your room you have your TV, you have a toy car, everything, walls. So all the objects they have a gravitational force. They are all the objects they are attracting you with the gravitational force. Just like the earth is attracting you towards it. In the similar way, all the objects are attracting you, but you do not know because the extent of the gravitational force between these objects is very small. It's very, very small. So that is why we are not able to feel the gravitational force of other objects around us. We are only able to feel the gravitational force of the earth.
Okay, sir.
Okay.
Yes, sir.
Okay. Then Now we come to our next topic, that is pressure. So now everyone should pay attention. We are starting with pressure. So how we define pressure?
So pressure is like if we are holding a pen and writing, we are keeping a force and a pressure on the muscular
Mm.
muscular fingers. We are keeping pressure on fingers so that the pen we are holding.
Okay.
So
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 if I tell you, yes,
force applied on unit area is called pressure.
okay. Of course, you know the definition, that force applied per unit area. That is actually not only the force, it is the perpendicular force applied per unit area, which we call as the pressure. And that perpendicular force is also called as thrust. Okay. So the perpendicular force is also called as thrust. Hence, we define pressure as the thrust per unit area. We rather say it thrust per unit area. So thrust per unit area is called pressure. Now, why we want to see this? See, the effect of force. The effect of force, if you see the first line that I have written, it states that the effect of force, it depends on the area of contact. Okay. Effect of force depend on area of contact. Okay. So let us say you have a balloon and you want to uh, burst out that balloon. Okay. So you have a balloon here and you want to burst out that balloon. What are the different options that you have? So let us take an inflated balloon. I want an inflated balloon and I want to burst it up. Okay, so let's see. I think I can get some of. Okay, so here you have some of the inflated balloon. And suppose I take this balloon and now if I press the balloon with both of the hands, I'm pressing that balloon with both my hands like this, in this way. So will it be very easy for me to blast it out?
no, sir.
Yes? No. Okay, okay, I will be using a lot of force. I need to use a lot of force to break it, to burst it out. What if I use a pin?
We
If I
can
use
burst
a
it
pin,
without the pressure.
I can not without a pressure. I can burst with a
Sir,
very little force. I need to use a very little force then. Okay. So in that case, I will be using very little amount of force. If I burst out this balloon, so I can burst this balloon with a small pin with a very little effort. Okay. So what was the difference between both of them? When I was trying to burst it with my hand,
sir,
yes, what was, yes,
sir. When we keep a tape in the balloon and when we keep the pin in the track, it won't but
yes, yes, you are certainly correct. You are correct that if you put a tape and then if you fires it with a pin, so it will not burst out, but it will just puncture up over there. Okay, it will create a puncture over there. So the air will try to escape out from there. It will not burst out. Okay.
sir,
But what I am asking, I am trying to burst out this with two methods. I have two methods.
sir,
Okay.
sir.
Yes.
If we even though we apply our muscular force on the balloon, um, if we poke with the pin, the air will come out because we are applying less force in a per unit area.
See, when you are using both your hands, the area of contact is very large. The area of contact is equal to the area of your hand. So you are using a lot of area. But
Yes, sir.
when you are using a pin, then you are using a very small amount of area.
The thrust is more and the area is low.
Yes.
So
So,
then the force will become high.
so here we find out that the effect of force, it depends on the area of contact. effect of force, it depends on area of contact. So if I apply a small amount of force with a small amount of area, I will get an effect. Whereas to obtain the same effect, if I use both of my hands, so I will not be able to get that thing. The reason being, I have a larger amount of area. Okay. So here I will show you some other examples also where the effect of area matters. Okay. Have you ever heard of a bed of pins? Okay. Or let's say a bed of pins. Okay, see here. Can you see this man lying on this bed of pins?
Yes, sir.
Is he feeling comfortable?
No, sir.
Yes,
Hmm?
sir. Yes, sir.
He is
Yes,
feeling
sir.
comfortable.
Yes, sir.
He is comfortable.
It
Even
won't
on
pinch
this.
him. The pins won't poke him, or he won't get pain of those pins.
The pins won't poke him, sir, actually,
Why?
because they go on. They will not be there. They will go down.
So why won't the pins poke him? Even if he's sleeping on the pins. Okay, what will happen? Suppose he sleeps the same way, but there are not these many pins. There are just two pins. So what will
The,
happen? Will the
he
pins
will
poke
get
him?
pain. The pins will poke
Yes.
him, sir.
Yes, then the
Sir, he
pin
will
will poke him. Okay, if there is just one pin, two pin, or five pins, then he will be poked by them. And if there are so many pins, so he's not getting poked. Okay, why? What the reason being here that if there are a number of pins, the area of contact has increased. Okay, and by increasing the area of contact, we have decreased the pressure. The pressure has been decreased by increasing the.
When we take too much force on the nail, we get poked, right?
If there is a very large force, so it would require a very large force there. Okay, and since his body weight is not that large, his body weight is not that big. Okay, so here I add him. See, he is lying over here and is not getting poked. However, if there is just one pin, he will get poked over there. I'll show you some more examples. Okay,
Sir,
so
like those
yes,
pins, those pins are going downwards, and he's also going downwards. He's not getting pain. If the if one or two pins, it goes upwards, and he goes downwards, and he gets pain of it.
no. The reason is that if there are a number of pins, so they are combined together to increase the area. We define pressure as force per unit area or thrust per unit area. So pressure is inversely proportional to area. If you increase the area of contact, if the area of contact is increased, then the pressure will be less. Okay. Now let us see here and some other examples also. So this is a person lying on this bed of nails. Some other things I'll show you. Let's say, okay. So the next thing I'm showing you for the pins, where let's say the straps of school bag. Okay. So see, if you have the straps of school bags, nowadays you observe such straps. You observe here the bags, they have these wider straps. The straps of bag, they are made wider.
Because
Mhm.
And even thicker, sir.
because they won't cause high force, sir, on our shoulders.
The force is the same. They decrease the
We don't
pressure.
get we don't get pressure, and we won't get the back pain.
Okay. So if the straps of school bags with, let's say we have with thin straps. So if you have thin straps, then what will happen? See, like this. Can you see here? This bag has a thin strap.
So the
Okay.
force will be higher on the shoulders because
Sir,
the pressure will be high and the area will be low. Then the force will be high.
See,
the
the
weight of
force
the bag is more, and as the trap is the thinnest one, we will get a lot of pain, like pressure on our shoulders.
yeah. See, so the weight is the same. The weight is equal to the weight of the bag. The weight remains the same. The only thing is that if you decrease the area, the pressure will be more. And if pressure is more, you will get more pain on your back. Okay. So that is why the school bags, they are made with wider straps. So school bags have wider straps. Let's see, these are the wider straps that we have kept here. Then I'll show you some more examples, some more applications of pressure. Okay, so this is one we have kept here, the school bag. Then some other, okay. What about walking on a pebbled road? Okay. What do you feel walking on a pebbled road?
Double.
Walking on a pebbled road. Okay. So see, you have this pebbled road, and if you walk barefoot on it, so will you have what will
Sir,
happen?
barefoot means without any shoes,
Yeah, without any shoes and slippers.
just with normal legs.
Yeah, so here. So if you are walking barefoot on a pebbled road, and if you are walking barefoot,
Look at hurt. Look at hurt.
you will get hurt.
We feel pain,
Because we're
and
applying the force.
we get the poking sensation.
Yeah, you will have poking sensations here.
Pebbles
Okay.
will get
But okay, with the same pebbles, if I make a flat road, then do you think again it will be the same way?
No, sir. No, sir.
No, no. If you make a pebbled road, if you have a this is a pebbled road, and if you have a flat road which is made of those same pebbles, so now they will not poke you. The reason being, here on these stones are sharp. They have sharp points, sharp ends, and hence area of the stones becomes less. If the area of the stone becomes less, so the thrust increases. Okay. If the thrust increases, then you will feel a poking sensation. Okay. So here you can feel a poking sensation with the thrust, with the increase of thrust. So all these effects, they are created because of force and area, because the region here is area. Okay. We observe here that the thrust is inversely proportional to the area of contact. Okay. Now let us have here two types of nail. We have here a blunt nail and let us say we have a blunt nail and we have a sharp nail. So these are sharp nails. I want some blunt nails and I want to use them. Just okay, blunt and sharp nails. I want. Just as an example, I want to show
Sir,
you.
like nail and the screw are different.
See, screw is a specific type of a nail, okay, which with threadings on it. Okay, so see here, I have put here two nails. Can you observe them? One of the nail is a blunt and other nail is a sharp. So I make this nail A, let this be nail B. Your nail A is a blunt nail. This is not a sharp nail. And your nail B, this is a sharp nail. So which one of them will you use? A blunt
Sharp
one
one.
or a sharp one? So why should we use a sharp one?
Because we can easily uh, easily we can keep inside the wall. We can
Okay.
screw inside the wall easily as
Yes.
sharp.
Sir, we can
It is.
nail it easily anywhere we want. This is very sharp pencil.
See, the reason being here the area of contact. The area of contact for the blunt nail is very large and the area of contact for the sharp nail is very small. Okay. And we know that pressure is inversely proportional to area. Okay. If you decrease the area, you can apply larger amount of pressure with the same amount of force. Even when you are using the same amount of force, so you can use a larger amount of you can use a larger amount of pressure just by decreasing the area. So it's easy for us to put a sharp nail than to put a blunt nail. Okay. So everyone has understood?
Yes, sir.
Yes, sir.
Okay. So this was all the things that we have studied around us, where we have seen that pressure depends inversely on the area. Okay. You can do the same work just by increasing the area or decreasing the area. So area creates an important effect in the application of force, and hence we study it as a pressure. Okay. So pressure is thrust per unit area. The SI unit of pressure is Pascal. So let's say here pressure is measured in SI unit Pascal. So pressure, it's measured as P equals to force per unit area. Force will be measured in Newton. Force will be measured in Newton. Area will be measured in meter square. And the SI unit of pressure, SI unit of pressure would be Newton per meter square, or we will call this will be either Newton per meter square, or we can call it as Pascal.
Sir,
Yes.
in CGS unit, we can call it as dyne per centimeter square.
Yeah. For the CGS unit, you will have dyne per centimeter square. Okay. But in the SI system, we have Newton per meter square, and this Newton per meter square is also known as Pascal, based on the scientist who studied about the pressure. So it was Blaise Pascal. His name was Blaise Pascal, not Louis Pascal. His name was Blaise Pascal. So Blaise Pascal studied about pressure. So in honor of his name, the SI unit of pressure was named as Pascal. There are other units also for pressure. For example, you can hear about atmosphere. These are some other units. Atmosphere, bar.
Atmospheric pressure.
Okay. We also call it as atmosphere, bar, or we can also call the pressure in units of centimeter of mercury or of mercury. Centimeter of mercury or of mercury. They are the other units of measuring pressure.
Sir, what is mostly used, sir?
It depends on
SI
our
unit.
situation. No, it depends on our thing, what we use, what is suitable to us. For example, generally for studying the atmospheric pressure, we use the unit as atmosphere, okay, or the
Yes.
centimeter or of mercury. The pressure exerted due to the atmosphere. Okay, the pressure exerted by the atmosphere at the sea level is called as atmosphere, 1 atmosphere. Okay, so the pressure of 1 atmosphere, we write it as 1 atm, means 1 atmosphere is roughly equal to, it is roughly equal to 10 to the power 5 Pascal. Okay. 1 atmosphere is roughly is equal to 10 to the power 5 Pascal. We can measure the same pressure in bar also. The atmospheric pressure can be measured in bar. It can also be measured in centimeter of mercury. If you measure the atmospheric pressure in centimeter of mercury or of mercury, so 1 atmosphere is roughly equal to 76 centimeter of mercury. The symbol of mercury is Hg, or it is also equal to 760 of mercury. So 76 centimeter or 760 of mercury. Okay. So any other doubts here? Up to here, any doubts from pressure?
Sir, what is bar?
Bar. Okay, 1 bar is also roughly equal to 1 atmosphere. Okay. Bar is
Sir,
also a unit of, yes.
Sir, like atmosphere bar, centimeter of mercury, like 3 are same only, sir.
No, not same. We see 1 atmosphere is
Similar.
almost equal to 76 centimeter.
Yes, sir.
Sir,
Okay. So yes.
I heard the name barometer, right? It seems it's related to pressure.
Yeah, it's related with the barometer. Okay. Okay, instruments that are used to measure pressure, you can use barometer or manometer. Barometer or manometer, these are the instruments which are used to measure pressure. Barometer is generally used to measure your atmospheric pressure. Okay, students.
Sir.
So bye everyone. We'll meet again in the next
Bye,
class.
sir.
Yes.
Bye.
Okay, bye.
No, sir.
Okay, bye.
Sir, barometer and
Barometer, manometer. Okay, bye everyone.